This is what it looks like when you solve a block on a Bitaxe, and I'm going to show you how to set up your own node in Solo Pool, so this could be you. We're going to build everything from scratch. In the video description is a link to a Substack article where you can follow along and set everything up. We will set up Bitcoin knots for our Bitcoin node, optimized for solo mining, ckpool-solo for our mining pool, Electrum server, which can be used for your Bitcoin wallet, a web front-end called ckstats for monitoring ckpool-solo, and a web front-end called mempool-space for monitoring the Bitcoin blockchain on our node. So we'll have a quick look. So this is ckstats, so it shows things like how long our pool's up, our hash rates, and our best difficulties, all sorts of graphs. And good old mempool, hopefully you're used to seeing this, but this shows the view of Bitcoin blockchain through your very own node. We will configure most of the above both for Bitcoin's mainnet and optionally for testnet 4, which I'll refer to as testnet. Setting up testnet is optional, but if you set up testnet, you can mine to it and prove that everything works rather than hoping and trusting that it does. The process starts with selecting a machine. It will need a minimum of 8 gigs of RAM and a 2 terabyte SSD. It should have a 64-bit CPU, but it doesn't matter if it's Intel or ARM. I'm using an Odroid M2 16GB device for 2 terabyte NVE. These are like Raspberry Pi 5s, but a lot faster. I used to use a 1 litre mini PC, but the Odroids are faster and about the same price as a second-hand mini PC. You will need Ubuntu installed. I started with a minimal install of Ubuntu server, which has no GUI. You can also use Ubuntu desktop. I've assumed you know how to use a Linux text editor. I prefer VI. Nano is easier for beginners. If you don't know how to use a text editor yet, then go watch some videos on YouTube before proceeding. You're going to need to know how to open and save files, search for text, and make changes. The major steps in the process are: create a build environment, optionally add storage to store the blockchain on, install Bitcoin knots for Bitcoin's mainnet, optionally install Bitcoin knots for testnet, install ckpool-solo for mainnet, optionally install ckpool-solo for testnet. Then I'm going to prove everything works. Optionally install ckstats for monitoring ckpool-solo on the mainnet. Optionally install ckstats for monitoring ckpool-solo on testnet. We're going to install Electrum server for mainnet, Electrum server for testnet. Then we're going to install mempool-space backend for mainnet and mempool-space mempool-space front-end for mainnet. We can't install mempool-space for testnet at the moment because the current version we're using 2.5 doesn't support testnet 4. Many TCP ports will be created in this environment. The web interfaces are what you'll be able to point your web browser at. So here's an example of a web interface for ckstats mainnet, web interface for ckstats testnet, and for mempool-space. You probably won't need to worry too much about the rest, but I listed it all here so it's all in one place. I've added an extra 2 terabyte drive to my Bitcoin node. So this section of the video, we're going to show you how to mount that extra storage. So to begin with, we're going to go into super user mode for the whole time because we're going to need to execute a lot of privileged commands. Okay, so there's a command called ls-block and it tells you all the block devices. So I can see down here I've got one that's 1.8 terabytes, and it's NVMe, so that must be my new drive. So we're going to partition that one up. So what we'll do is we're going to use a command called parted to create a partition table. We're going to use GPT style partitioning, mostly just because it's more modern. And then we're going to create a new partition for the ext1 file system. So ext4 file system. And lastly, we're going to give this partition a name. We'll call it home. Okay, now that if we do an ls-block command now, we'll now see we've got, on our drive, we've got one partition and it's all 1.8 terabytes. So what we'll do is we'll ask the Ubuntu to create an extended 4 file system on that partition for us. And I've previously set this up so you won't get that warning. I'm just going to say yes and let it overwrite it. So now it's busy formatting it. Okay, and now we're going to test ordering it. So we need to add it to FS tab. Oh, actually, first of all, we'll give it a label as well. So there's a command called e2 label. So we're going to label that partition home as well. So we've got a partition label and a file system label. Now I normally like using VI, but Nano is a lot easier for beginners. So we're going to use Nano to edit the file system table. And I've already added an entry here. So all of this is on the substack, so you can just copy and paste. So I'm going to say I want to mount the home partition, so that home file system in the mount directory with these options. So we'll exit out of that. And now what we'll do is we'll just do, after changing all of that, after changing the file system tab file, we have to use systemctl to tell it to reload it. And now we can do our first test mount operation. So I'm just mounting that 2 terabyte drive there. So we'll just we'll use disk free and have a look here. So we can see on mount, we've got a file system mounted down to 1.7 terabytes free. And we're going to mount that over top of the main home. So we need to copy everything that's currently in home to our new temporary location. So I'm going to use the rsync command and tell it just to make a copy of everything that's in home to the mount directory. And because my home is pretty much empty, it had almost nothing in it. Now we'll just make sure that it really did copy everything okay. So if we have a look in home, so we can see just our one directory, and we have a look in mount, lost and found is on every drive, so you can ignore that. So I've got that same directory there. Maybe we'll have a quick look in Odroid and just see what's there. All right, nothing there. We'll do an AL. So we can see lots of little files there. So we'll look at that same directory on mount. So we can be pretty confident that everything's copied across. So you got two options now. So when you mount this in its final place, it replaces everything that's in the home directory. So you can either remove everything that's in home already. Because my home directory is so small, I'm not actually going to bother it. I'm just going to let it go over the top. So we'll use Nano again to edit that etc file system table. And this time we'll tell it, rather than mounting it in the mount location, we'll mount it on the home directory. So I'll save that off. I just realized I probably did this in the wrong order, because I can't probably mount home now. Let's have a quick look. No, all right, so I'll just edit that. I'll put it back to mount. Now I can tell it to unmount it. Now I can go and edit it and change this back to home. I should really do the daemon reload command. A lot of the time it just picks it up anyway, but let's just do it for completeness. All right, and I should be able to mount home now. Well, I'm not really winning here. Let's see what disk free is showing. All right, it's already, I think I'll just unmount it and remount it. All right, let's see what disk free says. All right, that's good. So it took us a little bit of a roundabout way, but we've now got our new 1.7 terabyte external drive mounted onto the home directory. So when I've when I download the data, it's going to go there. We can do that ls block command again, and it also shows that new 1.8 terabyte drive is mounted in the home location. Okay, so that's how we add extra space to, or additional drive to, our Ubuntu installation if we need it for the for downloading the blockchain. Because we're going to be building everything, we need to create ourselves a build environment. So just working through the guide here. So first of all, we're going to become the super user, because we're going to be running nearly all SU commands for the moment. So it'll save having to type sudo a million times. So these are all the software packages we need to install. So first of all, we're going to update the software catalog. And then we're going to upgrade the existing packages on the system. Now, when we do these next commands, sometimes they might fail the first time. So if they fail, just simply run them again. Usually it's fairly reliable. I've installed all of these already. So I've got one update, so I'll let the system run away and do that. These will take, all of these together will take a bit of a while to install all of them. They'll be quite quick for me, but I'll just show you the process once it finishes installing the updates for me. This must be quite a big update. Half a gig, 510 megabytes. Linux firmware. They're currently looking at changing this package because it has the firmware for every system, every processor, all in one gigantic package. So whenever any computer system has a firmware update, they have to update that package. Some of the options they're looking at is splitting it out by manufacturer or CPU type, just to make the download much smaller for everyone. For instance, if you've got an Intel system, you don't need to download the MIPS firmware, really, do you? Because you can't use it. All right, I'll tell it to apply these updates. Almost there. When you're doing this, make this probably a wider, like full screen if you can. It's actually wrapped to this line. There should be one line here. It's thinking, it's thinking. Almost done. Right, now we can start installing the packages. So this will take, remember, this will take quite a while for you because I've got these already installed, nothing's really happening. Do the next one, and remember, if you get an error doing one of these, just simply run the command again. Nearly always it will work a second time. And this should all be on one line. Next, because we're going to be verifying the signatures where possible of packages we download, we're going to need this package here as well. So that's our build environment all set up. We're going to set up Bitcoin knots for mainnet now. So if you go into the video description and the link, you'll find a link to this Substack, and if you just search for installing Bitcoin knots, it'll jump you to the right section. Bitcoin knots is the actual Bitcoin node software that we'll be using. I'm going to create two installations, one for Bitcoin mainnet and another for Bitcoin testnet. I'm creating a second installation for testnet so I can prove that it works rather than trusting that it works, and do about a test updates before putting them into production. You don't need to set up testnet to have a working Bitcoin node and local solo pool. The testnet setup is optional. This is the main repository for Bitcoin knots if you want to have a look at it. Alright, so Bitcoin knots, we're going to create a group called mainnet, and everything that's related to Bitcoin mainnet is going to be added to this group. Later on, we're going to create another group called testnet, and everything to do with testing is going to be added to that group. We're using separate groups so we can keep our testing and production environments separate. So we can just copy and paste this command to add mainnet. Now, I've already done this previously, so I get an error that it already exists, but that will just work for you. Now we're going to create an account for mainnet called knots mainnet, and it will be joined to that group. So we'll just copy and paste that. Now I've already created this account, so that's why I'm getting a warning that knots mainnet already exists, but for you that should just work. Now we're going to build Bitcoin knots from scratch. So let's become the new mainnet user and download the software. So if I check who I am now, I'm currently a user called Odroid, which is my root account. And I'm going to become the knots mainnet account with this one. So if I run who am I again, you can now see I'm now logged in as knots mainnet. Now we can clone the repository for Bitcoin knots. So we'll just copy and paste this in. Now this might take 5 minutes or so to download, but to make the video a bit better, I've already downloaded it in advance to save that time, and it creates a directory called Bitcoin. Right, now we verify that we've downloaded what we've downloaded is legit and has been signed. So we're going to change into that Bitcoin directory, and we're going to ask it to verify the downloaded code. Now when you first run it, it's going to say can't check signature right about here. And we see we've got a key here. So we take that key and we ask GPT to search for whoever owns that key and then import it. So it's managed to find that that key belongs to Luke, which is very reassuring because we know Luke has created Bitcoin knots, or is the lead developer of it. So if we go and run that command again to verify the downloaded source code, it'll now tell us that that signature is good. Now you will get this warning about the key not being certified, and that's because we don't 100% know that this is Luke's key. And the only way to really tell for sure would be to meet Luke in person and ask to get it off him directly, but that's not going to be feasible for most of us. So we'll just have to accept that this key that's been uploaded really is Luke. There's a high probability it is. So we just got the warning saying the signature is good. Now we can start the build process. I'm going to completely disable the wallet feature as it's not needed for solo mining, and this machine is likely to have a port directly exposed to the internet. I'm also disabling the GUI since this is running headless on a server. Sometimes you'll get an error the first time you run autogen.shell, so if that happens, run it again. So we're just going to copy in autogen.shell. And this is part of something called the auto make environment, and it generates some initial scripts that we can use to then configure the environment. So we're going to run the configure command next. So disable wallet, and without GUI, it completely removes the code from Bitcoin Knots. So if there's any vulnerabilities in it, we shouldn't be affected by it. So I'm going to copy and paste that configure, and I'm going to let that run. Now, configure checks your environment for things like where what your compiler is, where's it installed, where are all the headers and libraries, and it uses that to generate a series of make files. And we're going to run the make command next. Now, you can just type make on its own and hit return. This particular machine's got 8 CPU cores, but 4 of them are performance cores. So if you know how many cores you got, you can go -J and the number of CPU cores, and that will build that many, that'll compile that many jobs simultaneously, speeding up the whole process. So just run the make command. Now I've already run this once, so it finished straight away for me. The first time you run this, it's going to take about 20 minutes to complete, maybe even 30. So once you start it running, that's a good time to go have a break, cup of tea, coffee, anything like that. Once it's finished running, we need to create a config file next. Now the config file lives in a directory called .bitcoin in your home directory. So we're going to copy and paste the make dir command, and Bitcoin Knots comes with an example Bitcoin file. So we're going to copy that to that directory. That's what this one command does. Now the next thing we need to do is generate a random RPC password. So we're going to use a mechanism called RPC with things like mempool and Electrum and ckpool. So Bitcoin Knots includes the script for generating random passwords. So we're going to create a user called RPC admin. And if we copy and paste this, so this line we're going to need to add to Bitcoin Knots in a second. And this is the actual password for the RPC admin account. We're going to need to refer to this for a few times. So make sure you copy and paste that and put it into your favorite text editor. I've recording this video over several days, so I'll run this quite a few times over the different videos. So this is going to change for me, but this will stay fixed for you. Once you've got that, save it as something like mainnet RPC details, because you will need to refer to it multiple times. And you can see it looks roughly like that. So now we need to configure the below values in the Bitcoin conf file. So we're going to edit this with our favorite editor. That's VI for me. So I'm going to go VI. Now I'll give you a tip. If you're using VI, it has this horrible, almost unreadable blue color to begin with. If you're using putty. So if you go into change settings, go into window, colors, and we want to scroll down and find ANSI blue. There it is there. So normally this is 00187. If you just make it 0 and change this number to 187, so you got 2 of them, and go apply, it'll change the blue to this more readable color. So the first parameter we're going to set is TX index. So we're just going to search for that, and that's the one we want here. So we're just going to uncomment it. This tells Bitcoin Core to build a transaction index, and that's needed by like mempool and the Electrum server. The next thing is we need to configure the block maximum size. So this defaults to 4 megabytes. Now, when we mine a block, we need to add a coin-based transaction, and that's the one that pays us. So if we solve the block, that's how we pay ourselves. Problem is, if we mined a block and we made it exactly 4 megabytes, there wouldn't be any space to add the transaction to pay ourselves. So this just limits the block size a tiny bit, so we can definitely make sure we can add the transaction to pay ourselves. So I'm just going to add that in here. And we need to do the same with the Bitcoin, the block max weight. So we'll copy that. And the block max weight, that's just down a couple of fields here. The next thing we're going to set is max mempool. And we'll search for it again. There it is there. So max mempool allocates around a gigabyte of memory for Bitcoin knots to use for caching things. So it can speed up the initial block synchronization, but it helps in lots of different areas. The next field we need to search for is this one. I can't remember what this one does, but I know we need to add it, so we'll add them in. I think it's something about caching unfiltered transactions or something, not completely sure. Right, now we need to search for RPC auth. Remember how we generated that random password before? So we'll go back to our text file, and that's that RPC auth line there. So we'll copy and paste all of that into here. And the last thing we need to do is the ZMQ hash. So we'll search for that. Now, if you're busy mining a block and then somebody else mines and solves the block, what happens is anytime you spend on that block from then on is wasted because it's already been solved. So ZMQ is a messaging protocol, and it lets Bitcoin knots tell ckpool that somebody else has already solved the block, and then ckpool will tell your ASIC to stop mining it and start mining a new one. So once you've got all that done, we'll save that off. Now what we'll do is we'll do a test run of the whole environment. So we'll run that Bitcoin daemon, and what you want to do is see it start up without any errors. At the top there, you're going to see it flush out, so all those parameters you've configured, so there and there. And okay, my one's already downloaded the blockchain, so it's not showing new bits, but you want to see a bit here, and it's going to tell you that your percent progress, and initially it's going to be 0.0000. That means it's 0% finished, and it's slowly going to build up to 1.0, which is 100%. All we're doing at this stage is making sure that this starts up with no errors, and it can start downloading the blockchain. So if there's no errors, wait about 30 seconds to make sure, and then just press Control-C and we'll abort it. Now we need to go back to being a privileged user. So we're currently knots mainnet, so we're just going to do the exit command. And we're now back to my root user, which is Odroid. That could be Ubuntu for you. And we're going to create a systemd unit so that the service will start automatically on system boot. So you've got to make sure you use the sudo command in front of your favorite editor. I'm going to use vi. You might be using nano or something else. I'll go sudo vi and edit that file. And then you need to copy and paste in the contents of that to here. I'll just quickly go through it. So description, just what this file is, Bitcoin knots mainnet daemon. Don't start the service until after the network is online. Until after the network has been started, and we need the network online because can't do anything in Bitcoin without the without the network going. We're going to run the service as knots mainnet under the group mainnet to constrain it in case we limit any potential security issues. And the type of daemon is forking. And basically what that means is when the daemon starts, it's going to write a process ID out to this file, and that's how it's tracked. Exec start says what to run, so we're going to run the Bitcoin daemon, but this time we're going to run it in daemon mode, and we save the process ID to that file. Exec stop is how do we stop this daemon? So we use a command called Bitcoin CLI and send a stop command. Restart always means if this daemon ever stops for any reason, always restart it. Now when you're downloading the blockchain in particular, when it if it needs to stop, it can take quite a long time to write all the data out, and sometimes systemd gets a bit impatient and will just forcibly terminate the process. This tells it to wait 120 seconds, which should be more than enough time for Bitcoin Knots to flush out all its data. If it does need to restart it, this says to wait 30 seconds between attempts. Sometimes if it fails to start, you might get files that are locked and stuff, and so if you retry immediately, it'll just cascade fail. So this just gives it a time for chance for everything to clean up before trying to run it again. These last four are all security related. So private temp means it can only see its own temp directory, it can't see the system one. Protect system equals full means it can't see any of the Linux system, the main system. No new privileges, so it can't be escalated, rooted, anything like that. And private devices means it can't see any of the Linux devices, like your hard drive, for instance. It doesn't need to talk to any of those things. So once you've done that, we'll save that off. Next, we need to enable and start the service. So whenever you've changed a systemd unit, you should do a daemon reload, so the system checks for and sees changed files. The enable command, that says enable this unit at boot time. So that'll cause Bitcoin Knots to start automatically. And now start means manually start it. So we're going to manually start it running. And now we're going to ask for the status. And what we want to do is see it saying active and running. If it says anything else, you've got a problem, and you need to go back and just check the steps to see if anything's been missed. You do have a little bit of a log file down here, so if there's an error, check that. Also, the journal-ctl command, that also displays the more recent logs. You can check that and see if you can see any errors there. The other log you can check is the Bitcoin Knots debug log file. So if you run this, it'll show you the bottom of that file, and that might also have errors that might help you if it's not running. Okay, so if it's all running okay, the next thing we need to do is configure log rotation so that this debug log doesn't grow forever and ever. So we're going to install the log rotate daemon. A lot of systems might have that running already. I've already got it installed. And we're going to create this file here. So remember, you've got to run sudo when you're working on these files. So sudo vi and that one. And we're going to copy and paste in the contents of this. So this basically just says that's the file we want to rotate because it'll keep growing forever and ever. Run this under the user mainnet group mainnet to security constrain it. We don't care if it's missing. We don't care if it's empty. And by default, it's going to keep 4 copies of it, and this will cause it to compress old copies. All right, we'll save that one off. We're going to ask the log rotation daemon to restart to read our file. And then we're going to check to make sure it's running okay. So we'll just use that status command again. If it doesn't have a green thing here saying it's waiting on the log rotate timer or it's got any errors, that means you've made some kind of typo just before. So go back and recheck that. So if it's green, you're all going good. Okay, to make life easier, we're going to make the core executables available via the path. So we're going to return to being our Knots mainnet user. So at the moment, I am still Odroid, and I'm going to become Knots mainnet with this command. So I'll type who am I. So I'm now Knots mainnet again. Now, when you log in as a user, if there's a directory called bin in your home directory, the system will automatically add it to your path. So we're going to use that built-in mechanism. We'll create that bin directory, and we're going to link the Bitcoin CLI command so it appears in the bin directory. I've already done this, so that's why I'm getting an error, but that will work for you. Now, to save us having to log in and out, we're just going to ask the system to reprocess .profile. .profile is what checks for the bin file. Now we can check it out. So we'll run, we'll run Bitcoin CLI netinfo, and you should get stuff in. Initially, you won't see too much in and out, but there should be something pretty quickly starting to show. Get network info. These are all good diagnostic commands you can run. So it shows all sorts of stuff about the network connections. Get blockchain info. So about where, about the blockchain. So You can see I'm almost, so 1.0 means 100% verified. It's always got a little bit of work to catch up on. And get peer info. It tells you about people who you're connecting to and who are connecting to you. After completing this process and leaving the mainnet to download, 771 gigs of disk space was consumed. So that's what it is for me right now. And then the final optional but recommended step is to port forward TCP 833 from your internet router to your Bitcoin node. So port 833 is what the port that different Bitcoin nodes talk to each other on. If you enable that, that means other Bitcoin nodes can talk into you. And so if you do find a block, it'll be broadcast faster because all those connecting people will get it. If you can't do this, it'll still work, but it just relies on your Bitcoin node connecting out to tell everyone. Right, so that's now mainnet setup. The setup for testnet is very similar to mainnet. We're going to create a new group and a user account. So currently we're the NOT's mainnet user, and we're just going to type exit and become our super user again. So for me, that's Odroid. That might be Ubuntu for you. So we're going to create a group called testnet for all the testnet processes. I've already created that group, so that's why it tells me it already exists, but that won't happen for you. And then we're going to create a user called NOT's testnet. That's a member of the testnet group. So we'll copy and paste that in. We need to become the new testnet user and start the build process. We are downloading the source code again because we might want to test a different version of Bitcoin NOTs in the future, but before we upgrade our mainnet installation. So we're going to speed run this a bit this time because we've already done this once, so you might need to pause this video a few times. So we're just going to become the NOT's testnet user, so we can see that that's happened. We're going to clone that repository again. So I've already got this downloaded to speed things up. We're going to become the Bitcoin account, and we're going to verify the downloaded code. And this won't say it's a good signature, and we've not got the key there, so we're going to search for and import that key. And then the next time we run the git verify, it will tell us that the code has a good signature, so it's done by Luke. We're going to kick off the autogen for the build environment, and once that's done, we'll run the configure command again. Come on, autogen. Almost finished creating the make environment. All right, now the configure process. And then we're going to do make. Once again, I've already made this, so it's going to be quite quick for me, but if this is your first time, it'll probably take another 20 to 30 minutes for this step to finish. Now, just a little side note, it wouldn't hurt every 3 months or so to update the source code. So if you do want to update it, you just do a git pull, and it'll go check for any changes, download them, and you just run the process again. Verify the code, autogen, configure, make. All right, so we're going to need to do create the config file again, so we'll do that. We'll copy in the example Bitcoin file. We're going to generate another random password for the RPC admin user. So we'll copy all of that. So this is going to be different from our production NOT's mainnet install. I'm running this over several days, so once again, this has got to probably change video to video segment to video segment. And I'd save this and call it something like testnet RPC details because you're going to need it several times. You can see my one is similar to the example here. And we're going to configure the values in Bitcoin conf again. So we'll just edit that. All the same parameters, but one extra parameter. Whoops. That's better. Find TX index. So we'll turn that on. We'll find block max size. Put that in. set block max weight as well. Find max mempool. Max mempool. We'll set that. We'll enable this parameter. So just remember, just pause the video if you need to. I'm going through this quite quick because we've already done this once. Set up the ZMQ queue. Add our RPC auth user account. Right, and now the bit that's different is we now have a chain command. So we're just going to search for chain equals, and we're going to say this is for chain testnet 4. So that'll make it run testnet. Right, we'll save that off. We're going to do the same test run of the Bitcoin daemon. So the same deal. You won't be able to see this start up. Leave it running for about 30 seconds. Make sure there's no errors. If it does crash or something like that, you need to go back and recheck your config files. Once it's been running for 30 seconds or so, you can just press Ctrl-C and exit out. Right, we need to go back to being a privileged user. So I'm currently not testnet, and I'll type exit. And now I am my root user again, Odroid. So remember, when using, you got to use sudo when you're editing these files. So we're going to create a file called not-testnet.service, sudo vi. And once again, pasting all the contents, very much the same, except the description's testnet and it's referencing testnet in all the directories here. Because we've just changed the system D unit file, we're going to do a daemon reload. And then we're going to configure the system, the unit to start at boot time. We're going to manually start it. We're going to check the status to make sure it's definitely running. So same deal, you want to see it saying active running. If there's any errors, you can have a little look in the log there. You can use the journal command to also check for any errors and hints. And you can also use the tail command to look at the bottom of the log. Okay, so we need to rotate this log file. So we're going to edit this file. So it'll be sudo vi edit the file, and you'll copy and paste the contents in. Similar to before, except it's using testnet and it's in the testnet 4 directory, and we're constraining it to the not testnet user and the testnet group. Okay, we'll have a go at restarting the log rotate service, and then we'll check to make sure it started okay. If it didn't start okay, then there's a typo in the file you just did, so you're looking for the little green start indicator. Right, we're going to set up that bin directory, so we'll just change back to the not testnet user. Create the bin directory. We're going to symlink that Bitcoin CLI command. So it's going to fail for me because I've already done this, but it'll work for you. I'm going to reread that profile directory. Now we can run our test commands. Ask for the network info. Get network info. Get blockchain info. And get peer info. All right, so the final step is just like before, we forwarded port 8333. We need to forward port 48333 to the router this time. Now, also just regard to size, the Bitcoin directory for testnet, when it's all downloaded, testnet's only about 8.8 gigabytes. Now we start to get onto the good bits, installing ckpool-solo, the actual solo pool software. I'm going to create 2 installations again, one for mainnet and one for testnet. I'm creating a second installation for testnet so I can prove that it works, rather than trusting that it works. You don't need to set up testnet to have a working solo pool. The testnet setup is optional. The repository for this is this URL here, so if you want, you can have a look at that in your web browser. Okay, so first of all, let's start with setting up ckpool-solo. We need to start off as our super user. So if I do a who am I, I'm currently the Odroid root user. That's my root user. You might be Ubuntu. If you just finished setting up one of the other modules in these instructions, you might have to type exit to get back here, but start off as whoever you first log into the server as. So we're going to add the user ckpool mainnet, and it's going to be a member of the group mainnet. So we'll copy and paste that in. I've already done this, so I'm going to get an error, but that shouldn't happen for you. Now we need to become the new mainnet user and start the build process. So I'm going to, because we've gone through a build process before, I'm going to do this a bit faster than we did previously. So we're going to become our user ckpool mainnet. If I type who am I can see that I'm now ckpool mainnet. I'm going to clone the repository. So note this is all one line here. It's just because I've squeezed this up half and half, so you can see what I'm doing, that it's done that. So for you, it's going to spend some time downloading the code. Once it's done that, you can go into the solo BTC directory. Just for the future, if you ever want to do updates, when you're in this directory, you can do a git pull, and it'll check for any updates and download them. Right, now we're going to do the autogen.shell command again, part of the automake environment. And it's going to go and create all the scripts for being able to start the configuration process. And now we're going to run configure. So just like last time, it's going to go and check things like what compiler we have and where all the files are installed in our system, and update a whole lot of configuration files. And once that's done that, we're going to do the make command. So I've explained this previously, so I won't spend any time on it this time. And I've already compiled this once, so this should go through quite quickly. This might take, actually I'm telling a lie, it looks like it is compiling it. So this might take 20 or 30 minutes for you. Oh no, it has come through quite quickly. Okay, so there is a sample configuration file. It comes with a file already called ckpool.conf. We're going to just rename or move that and call it ckpool.original and create our own configuration file. And now we're going to create that file ourselves. So I'm just going to edit that file for my favorite editor, vi ckpool.conf. And we're going to copy and paste in this code, or this config. Okay, so before we created a random account, rpc admin, and we need to come back to that config file, and this is for the mainnet one. So remember, we created a mainnet and a testnet one, and this is the password here. So you need to copy and paste this and put it where it says random password. And that's that bit done. Now the next bit is the signature. So when you mine a block, this text is what will appear in the block. So you can put in whatever you want here. I think it's got a maximum of somewhere around 37 characters maybe. So you can say mined by Philip using ckpool-solo, whatever you want to see appear here when if you manage to do it. Now, ckpool itself is free software, but you have the option to make a donation to the author if you solve a block, and I think that's reasonable considering all the time that they've put into writing the software. So donation 0.5, so that means 0.5% of the mined block will be given as a donation. You can make this any number you want. So once you've done that, you can then save off the file. All right, now let's try starting ckpool and see if it's happy with the config. And what you want it to see is for it to start up and for there to be no errors. So this is actually mining at the moment, so you won't see this bottom bit, but that's good. So once it's run for 30 seconds or so, just hit Control-C. Okay, so now we need to get back to our being the super user. So if I check, I'm currently ckpool mainnet, and I'll type exit, and now I'm going to be my root user Odroid. So once again, that might be Ubuntu for you. And we're going to create this file. So note, you got to use sudo when you're creating these files. So I'll go sudo vi and the ckpool mainnet file, and then you'll copy and paste this all in. So I'll just quickly go through this. So this says we've got a description: ckpool-solo Bitcoin pool on mainnet. Start the daemon after we've entered multi-user mode, and we also need to have Knots mainnet running first, and we can't run without Knots mainnet. We're going to security constrain it by running it only under the user account ckpool mainnet and the group mainnet. This time it is what's called a simple daemon. A simple daemon is one that you just run, and it keeps running until you stop it. Under all conditions, if it stops running, we're going to start it running again. We're going to make the working directory the solo BTC directory where we run it. And to start it running, we're going to run ckpool-b, and we're going to security constrain it. And because of that, we have to tell it, add this -s socket option to say store some temporary files that it was going to create in the solo BTC directory. And then we security constrain it with these next four. So we give it a private temp directory, protect the system so it can't actually access the Linux system file system. It's not allowed to gain privileges, and it's not allowed to see any Linux devices like in the dev directory. So once that's done, we'll save that off. Because we've changed the systemd unit, we'll ask use system control to use a daemon reload. The enable command here says start this running at boot time. Now we're going to manually start it running. And next we're going to check the status. So what we want to do is see it saying it's active and running. So if it doesn't say that, stop here and fix whatever the problems are. You can see you're going to have a bit of a log down below here. You can also do the journal-ctl command, and it'll spit out the recent logging, so you can check that as well. Right, next step, we're going to configure log rotation because it creates this log file. So we'll edit this. Once again, you're going to have to use sudo and your favorite editor. So sudo vi, and we'll edit ckpool mainnet, and we'll just copy and paste all of this text in. So that's the log file. We'll constrain this log rotation service to run as ckpool mainnet and the group mainnet. Don't care if it's missing, empty, and it'll default to keeping about 4 copies and compress the old ones to reduce the space they use. So once that's done, we're going to restart the log rotate daemon. Whoops, let's put the S in there that I missed copying. And then we're going to request the status. And that's good. We want to see that it's green, and it's depending on the log rotate daemon. If it's not green, there'll probably be some kind of error here, or there's an error in the file you just created. ckpool creates a number of statistic files. So what will actually become the ckpool user again? Ckpool mainnet. Once it's running, you can look in these directories to see stats about how it's working. Sorry, that one might be an actual. Oh, right. I'm going to have a leading / there. So that's got the pool status file. I think ckpool actually only populates one of these 2 directories, but we'll have a quick look. So that's the different users that are currently mining to the pool. And I think this directory here, the workers, might always be empty. Yep, it is. Okay, so that's ckpool mainnet setup. We'll move on to doing testnet next. It's not essential that you do testnet. That's only if you want to be able to prove that it works, or be able to test the code before you deploy it. Actually, before we move on, you're probably keen to try this out if you've got it to this stage. So if you jump into your Bitaxe and come down to pool settings, you can now put in the IP address of your server or node that's running the software. the same port 3333 like on ckpool, and then your wallet address, and if you optionally you can put dot and a machine name. I just go .bitaxe. Password's not required, but you can put in XX, anything you want, it's completely ignored. And then once you've saved that off, you probably will have to do a restart. If you go back to dashboard and scroll down the bottom, it should tell you that it's now mining to your pool if everything's good. And if you just wait a little while, we should see the hash rate graph pick up. I've just changed it, so it's probably just there you go. So it's just kicked in after changing it. So you might have to wait 5 minutes to really see that kick in. The setup for ckpool-solo testnet is very similar to mainnet. So first of all, we've got to add a user. So we need to be the root user to do this. So currently I'm ckpool mainnet. So I'm just going to type exit. And now I will be my root user, which is Odroid. So once again, if you installed Ubuntu server on Intel, that might well say Ubuntu. So we'll copy and paste this command in. Now I've already done this, so I'm going to get an error, but for you it'll just create the account. Now we need to become the testnet user and start the build process. We are downloading the source code again because we might want to test a different version of ckpool in the future before we upgrade our mainnet installation. So just talking about that, so generally when a new version comes out, I'll come into here and I'll just change into the solo BTC directory, do a git pull, test it out. Does it work okay? Yep. Then repeat it on my mainnet. You can also, you don't have to use testnet, so you can just go straight to doing this on mainnet from time to time. Okay, so we'll become our testnet user. So if I do a who am I can see I'm now a ckpool testnet. I'm going to clone the repository. So note this is all one line here. It's just because I've split screen this that it's wrapping it. It already exists for me, but for you it'll probably spend 5 minutes downloading it. Then we'll change into the solo BTC directory. And if you're doing updates, this is where you do your git pull. So I shouldn't find any updates for me because I've just finished building this system. And we're going to kick in the automake system again. So just like before, we'll run autogen, which creates all the files ready to run the configure program. We'll copy configure ready to paste in. And then next comes the make command. So once again, you can just type make on its own, or if you want to use multiple CPU cores, you can go make -j and however many cores you want to use. And I've already compiled this before, so this shouldn't take very long. I don't think this takes too long the first time. I'm thinking maybe 5 or 10 minutes. And once again, we're going to move the config file provided and move that to the, we're just going to call it ckpool original. So we've got the original one there. And then we're going to use VI and edit that file, ckpool.conf. And we're going to copy and paste this in. So don't forget, we've got 2 of these. I'm only showing one because I'm filming this over multiple days and I've regenerated this about 1 million times. So you're going to have one of these files for mainnet, one for testnet. So this is the testnet one. So you'll copy your password here from testnet and that'll go where random password is. And then you put in whatever signature you want to appear. So testnet has no value. It's only for testing. So this is how you can prove the setup works. Like testing ckpool-solo on testnet, anything you really want, and then save that off. Now let's try starting ckpool and see if it's happy with its config. So we'll just copy and paste this. And you want to see it start up with no errors, and maybe just leave it running for 30 seconds. And once it looks happy, just go Control-C. Okay, so now we're going to set it up to start automatically. So we're currently the testnet user, so we just need to exit and go back to being super user. So I do who am I? I'm back to my Odroid user. And now I need to create the ckpool testnet service file. So don't forget, you got to create this using the sudo command. So go sudo vi, and you need to paste all of this in. This is all pretty much the same as before, except I've just put the word testnet in all over the place. So we'll save that off. We'll do our usual daemon reload command, and then we'll set the service to start at boot time, and we'll start it running right now. Now we'll check it to make sure it actually has managed to start running. So it should say, like this should say active running. If it doesn't, stop here and fix whatever the problem is. You're going to see if there's any errors, you'll probably see them right below here. You can also use the journal command to see if it's got any errors there. Once that's going good, we now need to set up log rotation. So we're going to use sudo and create this log rotate file. So we'll go sudo vi and I missed off the / sudo vi, and we'll copy and paste the contents in. This is just like before, except it's now being done for the testnet file. So you save that off, and we'll restart the log rotate daemon. So it reads our new file, and then we'll ask for the statement, the status of the log rotate daemon. And you want to see that it's green and it's waiting on the log rotate timer. If that's not the case, you might see an error down here, and it's just in something you've just done. So you'll need to check that. Just like with the mainnet pool, you can check the status of the pool in these directories here, except we're just looking in testnet now. Now we will be setting up ckstats next. We're going to prove that it works, and then we're also going to be setting up ckstats so that we can verify. Ckstats is a GUI, so you can see what's happening. To verify that our new configuration works, we're going to solo mine to testnet, specifically testnet 4. You can only do this section if you did the optional testnet sections above. So this is only, you don't have to do this, you can just accept that it works, but I'm going to show you that it does work. So we're going to start off by having a look at the hash rate over on mempool-space using this URL. Actually, I'm going to start off by looking at mainnet to say why we can't test it there. So if you're using a Bitaxe, it's got a hash rate in the terahash, around the 1 terahash region. Now on the Bitcoin mainnet, we currently have a hash rate of, where is it hiding? 937 exahash, right? Exahash. So if we go over to testnet, so testnet lets you generate Bitcoin, but they have no value. It's only testing. So rather than exahash, it's now in the terahash range. So currently it's 500 terahash a second. And this can vary all over the place. I wonder if this graph will let me see it. No. So it might be, you can see here, recently someone pumped up it to 2 petahash, and then it'll dive down again. So testnet is all over the place, but generally it's in the it's in the terahash range. And so when you got a Bitaxe of a 1 terahash capacity, you need to be on testnet to stand a chance of mining a block. So at the moment, it's around sort of 500 terahash a second. So if the testnet 4 hash rate is around 500 terahash and you have a 1 terahash miner, then you have a 1 in 500 chance every 10 minutes of solving a block. A block is meant to be solved every 10 minutes, but the testnet can be a bit all over the place. That means there's 6 blocks an hour or 144 blocks per day. If all of these numbers held, then you could expect to have to leave the solo miner running for between 2 to 4 weeks before solving a block if you have about average luck. To start, we're going to need a testnet 4 wallet. I'm going to use Electrum. So you can get Electrum from this URL. So I'll go over here and I'm on Windows. So I'm just going to get the Windows installer version. And then I'll run and install that. Nothing special at this stage. Now once it's finished, we need to edit the desktop shortcut and add a ---- testnet 4 parameter, and that tells Electrum to run in testnet. So I'll come back once this is finished installing. Once Electrum's finished installing, you need to go to the shortcut for it and do a right-click properties. and on the end put a space and go ---- testnet 4, and we'll save this off. Right, now we can start Electrum running, and we're just going to do a very standard simple setup of Electrum. Okay, I ended up leaving and coming back to this, so it took quite a while to start up for me. So we had that ---- testnet 4. I'll get rid of that. So we'll just go next. Default wallet's fine. Standard wallet's fine. I'm going to create a new seed in here, but I've got another wallet that I've already done with the test mining too, so I'll come back and set this up again later. Just waiting for Electrum to let me get to the next page. Whoops. Right, I'm not going to save the seed phrase here. So remember, this is only testnet. This has no value. I'm going to confirm I've saved. Oh, it's going to make me actually save them. All right, let's put these in a text editor. Paste it in there. I wonder if I can paste these back again. Yes, I can. All right, that saved me some time. I'm not going to bother with a password. I'm not going to bother with updates. This will be wiped soon. It's warning me I'm testnet mode, so that's a very good sign. Make sure you're seeing this. It's warning me these coins are worthless. Let's see. I'm going to go to View Addresses, and on the Addresses tab. Now, one important thing to note is testnet addresses begin with TB. I'm guessing this is short for test Bitcoin, and we're going to mine to one of these addresses. Okay, we've got nearly everything ready now. So you remember how we're mining to port 3333 for mainnet? Well, we're going to use 3433 for testnet. So if we whip across to our Bitaxe and we go down to the pool settings, we'll just change the port to 3433. We'll grab our test Bitcoin address. It can be any of these. I'm just using the first one. And so you can see a normal Bitcoin address begins with BC. I'm guessing BC for Bitcoin. And we'll put in that. So that's TB for test Bitcoin. And then we click on save, and now it'll start mining to testnet. And this is what it'll look like when your Bitaxe solves a block. And then if we head back to our wallet, we'll go to Tools, Preferences, and we'll just change the unit from millibitcoin to Bitcoin, which is what more people understand. And I'll go and look at my history, and there you go. I can see that I have now received 50 test Bitcoin for the block that I solved. So that's the system completely proven to work. I've used a Bitaxe, mined to ckpool-solo and testnet, and then received a payout to an Electrum testnet wallet. Now, because this process might take a while, maybe 2 to 4 weeks at the moment, you can carry on doing the rest of the install guide and getting the GUI and everything installed rather than waiting. So we'll do that. We'll carry on with that next. ckstats is a web-based GUI for monitoring ckpool-solo. We'll create 2 installations like with the other systems, mainnet and testnet. You don't need to set up testnet to have a working solo pool. The testnet setup is optional. This is the source code for ckstats if you want to have a look at it separately. So first we need to add a user account to run the mainnet GUI under and install the required packages. So we need to start this from our root user. So if I go, who am I? I'm currently ckpool testnet. So I will exit out, and I am now back to being my Odroid account, my root user. So I'm going to add an account called ckstats mainnet and join it to the mainnet group. So this would exist for me, so I'll get an error, but for you it should create the account just fine. And then we need to install Postgres, the database used for installing stats. So we'll copy and paste that. Now this is already installed for me, so it'll be quite quick, but it'll take a bit longer for you. Now we need to create a table in Postgres. So we're going to run the Postgres command, which is psql. And we're going to create a user called ckstats mainnet. Now I've already created this user, so I'll probably get some kind of error. And then we're going to tell it to create a database with the same name. So we'll copy and paste that in. So my database already exists. And then \q to quit out of this tool. So now we need to become the new mainnet user and start the build process. So we'll copy and paste this to become ckstats mainnet. Who am I? Yep, I am. So we need to install this little facility here. So we'll just copy and paste this command, the PNP environment used for JavaScript code. That updates the bash RC file, so we'll just tell it to run that again. And now we can clone the ckstats environment. So this time I actually deleted my ckstats just before running this, so I did get to download it. And we'll go into the ckstats directory. So we need to create a file called .venv. So I'm going to use vi.env. And we'll just copy and paste all of this into it. And save it up. Next up is building the ckstats environment. So we're going to paste these commands in one at a time, and just note we're going to get a warning about having to approve the build, and we'll need to run this command and approve for this ES5 util. So we'll run the install command. So it's grabbing all the stuff. So this is the warning I mentioned about having to approve the build. So we'll run this approve builds command. And I'm going to say A for all, even though there's one, and then just hit return, and then say yes to approve. I'm going to update the browser list database for this package. So I'll just run this command to do that. And we'll say yes, download the latest list of web browsers. And then we'll run the migration command. So if there'd been a prior version of the database or any changes, this migrates the database into the current format. And C just loads some initial data into the database. And then this does the main build part. So this is JavaScript, so it's very different to the C code we're running before. So you can see the build process is very different. Okay, I'll come back once this section has finished. Now that the build process is finished, let's have a test go at starting it running. So we're going to start it running on port 3334. And it does take a little while just to kick in, and we'll go to a web browser and we'll go to our machine. And that's good. We can see we've got a, right, not sure what Edge is trying to do there, but we've started up the GUI. Okay, so we'll return to the command prompt and we'll just hit Control-C. So if you don't get the web GUI coming up, and you know you've done something wrong, you need to stop and go back. Right, we've just now Control-C to edit. Now, 3 scripts need to be scheduled to run. First, run them one at a time and make sure there's no errors. So we'll just test that again. So make sure we can run the seed script, the update user script, and the cleanup script to get rid of old users. Okay, so we're going to use cron to run these regularly. So we're going to run the cron tab -e command. And I've already put these in, but basically you copy and paste these. These are just 3 lines into here. And once they're in there, you can save that off. So the last thing we need to do is create a system unit to start everything automatically. So we're going to return to the super user. So we're currently ckstats mainnet, and now we're Odroid, and we're going to create a file called ckstats mainnet.service. and we're going to copy and paste everything from here into it. I'll just quickly go through our first one. So the description is ckstats on mainnet. It has to start once we've reached multi-user mode. We need ckpool to be running, and we need the Postgres database to be running. We need to start it after those things. We need, and to be able to run, we need ckpool and Postgres. So we're going to security constrain it to the ckstats mainnet user, to the mainnet group. It's a simple service, and we start it running from that ckstats directory, and we simply start it on that port. If for some reason it crashes, we'll wait 30 seconds before trying it again, and then these are our usual 4 commands we do to security constrain it. So if we carry down the instructions, when you change a file, you've got to do a daemon reload. This will be all seeming a bit familiar now. We'll enable this to start when the machine boots up. We'll try manually starting it. And then we'll go to the status command. And you want to see it saying active and running. So if it doesn't say that, you need to go back and just check the things that have just been done. If it's not working, you can try using the journal ctl command, and it'll spit out some of the recent log. And you should also be able to revisit their website and have that come up. This works much better when it's full screen rather than just compressed to one tab, but you should see lots of data starting to appear. On to ckstats testnet interface. The section is optional and only if you want to monitor the testnet ckpool. Let's add a user account to run the testnet web interface under. Start this process as your root user. So I'm going to do a who am I, and I'm already my root user Odroid. So if you're not that, you might be Ubuntu, but get back to your root user. And then we'll add the testnet account. Oops, let's try that again. So I've already added it, so it already exists. So we create the user ckstats-testnet and join it to the group testnet. Right, we need to create a database for it. So we're going to become, as the Postgres user, run the command psql. We're going to create the user ckstats-testnet. I've already created this, so I'll get an error. And then we'll create the database ckstats-testnet. And then we'll quit out. Now we're going to become the testnet user and start the build process. So we'll become ckstats-testnet. And I'll just do a who am I and confirm. And we're going to download and run the package manager npm, which is used for the JavaScript. And now we're going to run the updated bash rc file that it creates. And now we're going to clone the repository. Now we'll change into the ckstats directory it's created. And we're going to create a file called .env. So I'll use vi. And I'll copy and paste in that config. And we'll save it off. Next up is doing the build environment. So we'll let it run install. We'll approve the builds like last time. I'll press A for all and then Y for yes. We'll update the browser list database. And then after that, we'll run the migration script. After that, we run the seed script, which puts the initial data in the database. And then we'll start the build process running. This will take a little while, so I'll come back when it's finished. The build process is now finished, so let's try start running it on a test port. So we're going to try and use port 3434, so we'll try web browsing to that and see if it's coming up. Yep, that's good, and we're getting a pool load up. So we'll hit Control C on that. Now we need to just check that some scripts we're going to be scheduling all work individually. So we'll run seed, update users, and then clean up. Perfect. Right, now we've got to add those 3 scripts as scheduled jobs. So we'll add those to cron tab. I'm just going to use nano number 1. Oh no, I actually wanted VI. Never mind, I'm sure it'll be okay. So I'll copy and paste those 3 files. And save that. I'll just run it again. Yep, that's saved nicely. Okay, so we've got to create this test file now. So we'll do our exit, and we'll run the editor to create our testnet service. And we'll copy and paste this in. I won't go through this because we've done that previously. So we'll do all the normal stuff we do. We'll do a daemon reload. We'll enable the system to run at system boot. And we'll start it running manually. We'll check the status. And you want to see it saying active and running. If it doesn't say that, you need to stop and go back. And we'll check the journal. So if you're experiencing errors, you can have a look in here, and then we'll just have one last check to make sure it's all started up okay on its own, and we can see it. Perfect. All right, that's ckstats on testnet done. Electrum server is required if you want to run mempool.space, or if you want to use the Electrum wallet. If you don't intend to run mempool-space, you don't need to do this section. If you want to have a look at this manually, this is the GitHub. So first of all, we're going to set up mainnet, and we need to start off being our root user. So for me, that's Odroid. For you, that might be Ubuntu. And we're going to create a new user called Electrum server-mainnet and join it to our group mainnet. So we'll copy and paste that in. So I already got this user, so I'm going to get an error, but that'll work for you. We're going to build Electrum server by Romans from scratch. Let's become the new mainnet user and download the software. Now we're going to clone the Git repository. Now I've already cloned it to save time on the download, but for you it'll spend some time downloading it. Now we verify that what we've downloaded is legit, has been signed. When you first run these commands, it will say can't check signature, no public key. However, at the time of writing this document, this current tag is not signed. So we'll just change into that Electrum server. But perhaps sometime in the future they'll sign the code so you can tell it's authentic. So we just get cannot verify it. We don't get a signing method, so we're going to skip this parts. Okay, so we're in our Electrum server directory. We're going to run the command cargo clean. And then we're going to paste in these 2 environment variables. And then we're going to ask it to build it. Once it's finished being built, we're going to make sure we've got a bin directory in our home directory. You can see it's marching through 62 files of 192 done. This is built in Rust, I believe. 111 of 192. So what Electrum server does is it provides a way for applications to look up things by transaction much faster than they can directly to Bitcoin Core. And Electrum server basically goes through and indexes all of the transactions in the main Bitcoin database to give that speed increase. Oh, 170, only another 20 odd files to go. Must be hitting some bigger files now. 180, 12 to go. These are obviously harder to compile, these files. Mentioning things like crypto and stuff. Oh, it feels like it's slowing down, doesn't it? Five to go. Come on, Electrum. Well, these last ones must be really hard. I keep thinking it's about to finish and move on, but it's just stuck on this number 187. Hopefully it'll blast through quickly after this. Come on. Not sure what the Electrum RocksDB does. I'm guessing maybe that's the main database engine it uses for storing everything. So you've got a feeling RocksDB is was created by one of the big social media companies. Let's see if we can find out while we're killing time. Yeah, created by Facebook originally. Wow, it's still compiling. Wow, at this rate I'll be stopping the video and then carrying on when it finishes. We'll give it another minute. Alright, I'll stop this and we'll resume on when it's finished compiling. Alright, that finally finished compiling. It felt like ages. So we'll just make sure we got that bin directory in our home directory, and we're going to link the Electrum server to place it there. Now, I've already done this, so I'm going to get an error, but this should work for you. And then we're just going to reread our profile to make sure that's on the path. Right, now we're going to create a config folder on Electrum server. I'm going to use VI, but you use your favorite text editor. So we're going to create a directory to store the configs in Electrum. And then we're going to edit the config, or create the config file. Next, we've got to copy and paste the contents of this into the file. The main bit that needs to be changed is, so we got auth equals rpc admin, and then we've got to put the password in. And this is from your mainnet one, and it's that password there. Okay, so once you've got that all saved, once you've got that all put in, just save it off. Now, time to test everything works. If you get any errors, resolve them before continuing on. And the index will need about 24 hours. What that is once it started as a service. If there's no errors after 30 seconds, hit Control-C. So next thing we've got to do is set up a systemd service. So that's all going fine. I'll hit Control-C and I'll exit out. And we've got to create this file here, and remember you've got to use sudo when you're creating these files. So I'll copy and paste that file name. And so I'll just go who am I, so we can see that I'm my super user. Sudo vi in that file. And we copy and paste all the contents in. Because I've described these files quite a few times already, I won't bother going through this again. And this process will be coming very second nature for you. So we'll do a daemon reload because we've just changed to systemd unit. We'll enable it to run at system boot. We'll start the service running. Then we'll use the status command to make sure it's started up okay. And we're going to set saying active and running. So if that's not the case, something's gone wrong. And if something's not working, you can use this command just to print out the log, and that might give you a hint. Alright, that's mainnet all set up for Electrum server. Now we're going to build Electrum server for testnet. So remember, this is optional. You only need to do it if you want to be able to run things on testnet. So we're going to start off as our root user. So that's Odroid for me. And we're going to create the user account for Electrum server. So the account's Electrum server belonging to testnet. I already have the accounts, that's why that says that for me, but it should be okay for you. Then we're going to become that Electrum server testnet account. And we're going to use git to clone the repository. I'm going through this a bit faster because we've done these kind of things many times before. So I've already downloaded it, so that's why I get that warning. We're going to change into the Electrum server directory. I have a quick go at doing a git verify. Okay, so the code at this point is not signed, so we can't do the git verify bits. So we'll do the, we'll carry on and do the cargo clean command. We'll paste in our 2 environment variables. And now we'll do the build process. Now, last time the build took quite a while, so I'll come back once this process is finished. Okay, that's the compiling finally finished. So we're going to create a local bin directory in our home directory. We're going to link the Electrum server to it, and I'm going to get an error because I've already got that done, and we're going to read our profile file. Right, now we need to create a file to run Electrum server. Whoops, where did that go? Oh, there it is. I'm using VI, so you should use your favorite editor. All right, let's create that directory, and then we'll edit the config file. So copy and paste in all the contents here, and just remember you've got to replace that password with the testnet password from here. So once you've done that, we'll save it all off, and then you can test running Electrum server. So it should start up and no warnings or errors, and basically just let it go for 30 seconds or so, and then once that's done, hit Control-C. So we'll set it up as a systemd unit now. So we'll exit back to the super user. Well, so first of all, you can see I'm the Electrum server testnet user. So I'll exit out, and I am now my Odroid super user. So we're going to create a file using sudo and your favorite editor, vi for me. So I'll go sudo vi and create that file. And we'll copy and paste in all of that. I won't explain it because we've done that about 1,000 times. And this will be almost routine for everyone by now. So, whoops, so we go away, Copilot. That was a bit painful. Wow, it's really taken me to completely the wrong place. Let's get down here, Electrum server, testnet. Right. This is where we are, so we'll do a daemon reload because we've just changed our systemd unit file. We'll enable it to run at system boot. We'll start it manually. We'll get the status to make sure it's running. And we want to see it's active and running. That's perfect. If there's any errors, you might be able to see the error down here to help fix it. And you can also run this command to get the recent log, and if there's any problems that you might see an error there. On to installing mempool-space. This section relies on node.js having been installed, which was done in the ckstats section. Note that mempool-space version 2.5.0 does not properly support testnet 4, so we won't be deploying that. So this will be only running on mainnet. And this is the repository for mempool. So mempool has got 2 components, a backend and a frontend. So we'll start by configuring the backend for mainnet. So we need to start as our super user. So we'll go, who am I? So my super user is Android. That might be Ubuntu for you. And we need to create the database, create the user and the database. And just a special note that the grantor identified via line, which is this one here, this is all one line. So you need to paste that in one go. All right, so we're going to create a new user called mempool-mainnet and join it to the group mainnet. So that user already exists for me, but that'll work for you. And mempool uses MariaDB, so we need to install that and the client for accessing the server. And we'll now become that MariaDB. It actually creates a user account for you. And we'll tell it to create a database called mempool mainnet. Now I've already done this, so I'm going to get an error, but this will work for you. And then we've got to do this great big grant war. So remember, this is all one line. So that basically says grant the Unix user called mempool-space -mainnet on this server access to everything in that database. All right, and then we'll do the quit command to exit out. Whoops, quit command to exit out. So we're going to become our mempool mainnet user now. And we're going to clone the mempool repository. So remember, I've already downloaded, whoops, missed the G there. Let's try copying that again. I've already downloaded this to save time, but that'll download for you now. And we'll change into the mempool. Now, there is a newer version of mempool, but it's not compatible with this version of Ubuntu. So we're going to grab the last of the version 2s, which is currently 2.5.0. Otherwise, we're going to have all sorts of grief. And we're going to try and verify that this code is signed and authentic and no one's changed it. So we've got that key there, if you remember from before. So we're going to tell it to search for, download and install that key. And what it's told us here is that key is not known publicly. So when you get ones like this, you really can't do too much more. If you want, you could take a look at the GitHub, and under Insights contributors, there is a user called Wiz with a GPG key. You could choose to manually download and install that key. Well, maybe we'll do that then. I generally prefer to search the public databases than downloading from random websites, but this is from the GitHub repository for a major contributor for it. And now we'll ask it to check the signing again. And so now it says that is a good signature by Wiz, which is all over that repository. Okay, so there's multiple directories. There's a directory called backend, which contains the backend code, and we're going to tell this to run the install process, and then we're going to run the build process. All right, I can't remember how long this takes, but hopefully it's not too bad. So this one's all JavaScript or TypeScript. Oh, goody, it's finished already. Okay, so they provide a sample mempool file. So we're going to copy the sample file and make it our new config file. So copy and paste it in and run that command. Okay, let's scroll up a bit. So now we're going to edit mempool.config.json using our favorite editor. I'm going to use VI. Copy, there we go. And we're going to look for a section that says mempool. So I'll just go to the very top. All right, so there's the mempool section. So we're going to look for automatic block reindexing. All right, maybe I'll search for it. There's so many entries there. So we're looking for an index, an entry under mempool. There it is. So automatic block reindexing, set that to true. And we're looking for a section that says core RPC. Oh, here it is here. And we have a username and password. So the username is going to be RPC admin. And then the password is going to be from your, that password there from mainnet. So the mainnet password that you copied. Right, now we need to find the Electrum, it's the Electrum section, that's it right there. Let's scroll down and get it into the middle of the screen. So we need to change the port to be 8335 and TLS enabled needs to be set to false. There's a section in here called Explorer. I've already deleted that, but basically just search for that and then delete all of the lines. And there's another section called Second Core RPC, and wherever that, I've already deleted it, but you delete the whole section. So the section is like that. It goes from the word, open brace, config, close brace, comma. You delete the whole section. Okay, so now we come to the database. Here it is right here, the database section. So we got to fill in the socket, which is this value here. The database is going to be mempool mainnet. And then you got to fill in the username, which is right here, mempool mainnet. Password field's not actually used. So once you've got all those config changes done, we can do a test run of the back end. So we'll copy and paste that npm run start command and just leave it running for a while. It actually takes about a minute or so to actually start up. But once it's finished going for all of this and it's started up, you can just stop it again with Control-C. If there are any errors, just like all the other times, you got to fix them before you proceed. Now we've got to create a systemd unit. So I'm using my favorite editor, so you've got to be the super user. So we'll type exit and get back to the super user. I'll go, who am I? I'm my Odroid user. I'm going to use sudo and vi and edit the systemd unit. You copy and paste all of this. We've done this so many times, so I'm not going to explain that. And then we got our usual commands. So we'll do the daemon reload. We'll do the enable it so it runs at boot time. We're going to start it running. And then we'll do the status command. And we want to see that it's active and running. Note that it does take like maybe a minute to fully start up this thing. It's quite slow. And then we'll use the mempool. We'll use this command if there's any errors. It just lets us see the log. And you just want to see there's no errors and everything's working. Right, we're now on to the last major component, the mempool-space front end. And once again, this is only for mainnet because mempool.space supports the old testnet, but that's pretty much dead now. And we're using testnet 4, which is the current version of testnet. So we're going to be, because it's all part of the same package, we don't need to create another user account. We're just going to go straight back into our mempool mainnet user. And this time we're going to change into the front end directory. We've already built the package, so there's nothing to do. And we're going to copy, make sure that's all one line. We're going to copy that config file from the example to the version we're using. Now we just run the install command. Oh, I tell a lie, there is a build process, but at least it's only for the front end this time. Install's having a bit of a think. Yay, that's done. And now we'll run the build process. Hopefully it'll be like the back end and won't take very long. It's thinking. All right, what I'll do is I'll come back when this process is finished in case it's going to take a while. Now that the build's finished, we're going to just test it out and start it running. Now, when you run this can take maybe 2 or 3 minutes, a good couple of minutes at least, till it actually starts working. And you'll need to wait until you see it mention something about port 4200. So I'll wait and then I'll stop this video and then we'll come back to it once it's finished getting to that process, that step. Okay, it's finished starting up now. Yeah, it finishes off saying that, and that's where it mentions port 4200. So if we go to HTTP and the IP address of your server and port 4200, we should see mempool.space appear. There we go. And that's showing the mempool of your very own node. Okay, let's carry on with the rest of the setup. I'll close that off. Okay, so if all's working well, hit Control-C, and it is. If it's not working, then fix any errors before continuing. Now let's run it again, but talking to so by default it talks to the mempool backend, mempool.space, the public internet website, talks to its backend. So now we're going to run it again, but talking to our backend. And if there are any issues to do with the backend, to see if there's any issues to do with the backend config, look there to fix any issues, aka the backend config. So we'll tell this to run again. So I told a lie before, it was a local mempool.space, but looking at a remote node. So now it's going to be looking at our backend at our node. So I'll come back once this is finished starting. I'll come back once this is finished starting up. Okay, that's finished starting up. So we're going to open up another tab and we'll browse to our local server again, port 4200. So we're talking to the same front end, but this time the front end is talking to our own back end. And yay, that's all working nicely. Okay, so we'll go back to here. So once it's working, we'll just hit Control C, and we need to create a systemd unit for it. We need to start off as our root user. So if I check, I'm currently mempool-mainnet. I'll type exit and I'll be back to Odroid, which is my root user. It could be Ubuntu for you. And we're going to create a new service called mempool frontend. So we'll do our sudo vi, and then we'll copy and paste in this config. It's very similar to all the others, so I won't go through it. And our normal routine, so we do a daemon reload, because we've changed the systemd unit. We'll enable it to start at system boot. We'll start the service running. We'll ask for the status to make sure it's started up and there's no errors. That's what we want to see. It's active running. If there's any problems, check out the log down here. And we can also spit out more logging with this command. Right, note that after starting this front end, it can take 1 or 2 minutes. So when you do this, from when you do the start, it might take 1 or 2 minutes before you can actually go to the web interface. So that's it. We've got mempool all set up. If you've made it this far, you've done an amazing job. And please let me know when you solve your first Bitcoin block.